Okay, so let's pick up where we left off yesterday. And if you weren't here yesterday, you should have hopefully watched the notes from yesterday. I posted them. I did not scan my completed notes only because I will scan them once. I always scan once we're all done with a section. So we are talking about transforming and combining random variables. So yesterday was focused on how to transform a random variable. If you did not watch the video from yesterday, make sure you do. The transformation and combining random variables almost always comes up on the AP exam somewhere, okay? I said, do not confuse transforming a single random variable with combining two or more separate variables. So what we did yesterday briefly is we took a random variable x and we did some mathematical transformations to it to create a new random variable y. What we're going to do now is we're going to start with two separate random variables and then put them together, okay? So in this example, I said two insurance agents are working to bring in new clients. One of the agents is more experienced and tends to bring in more than the other, newer employee. So we're going to let X equal the number of clients signed by the new agent. So X is the number of clients, and I'll put that here to remind you, okay? This is number of clients by the new employee, and Y is going to be the number of clients by the experienced employee. So you can see because the employee is more experienced, they are able to bring in 3 or 4 clients, while the newer guy only gets 0, 1, or 2. All right. And then we have their probabilities listed beneath. They're both legitimate. They add up to 1. All right. So in order to save a little bit of time today, I said here, find the mean, the range, the variance, and the standard deviation for X and Y. Fill in these values in the spaces below. Okay, so in order to save time, I'm not going to take class time to do this. The question is, would you be able to put these numbers into your calculator and get the mean, the variance, and the standard deviation? Okay, could you put these in your calculator? Now this one should be pretty easy for the mean. It's going to be 3.5 because it's dead center with equal probabilities, okay? The mean of X, okay? The mean of X comes out to be 1.2, which by the way, if you look at this, if I covered up the probabilities and I just said, okay, the new employee brings in anywhere from 0 to 2 new clients. What number is smack dab in between 0 and 2? 1. So if the probabilities were equally balanced, the mean would have been 1, but because there was more probability off to the larger side, that's actually what brought that up to 1.2. The mean for Y, like I said, is pretty basic. It's right in between 3 and 4, 3.5. The range for X and Y. Well, the range, this guy brings in anywhere from 0 to 2, so his range is 2. This guy brings in anywhere from 3 to 4, so his range is 1. Don't even need a calculator for that. Now the variance, if you did put all this in your calculator, the variance comes out to be, I have 0.56. And then if you square root that, you come out to have about 0.75. The variance for Y is 0.25. And if you square root that, you get a standard deviation of exactly 0.5, so 0.50. Okay? And I'm saving again some class time, assuming that you would be able to get those numbers out of your calculator. If not, okay? All right. What we're going to do, though, now is we're going to combine these random variables. If the two men combine their new client list, how many new clients would be possible? Well, let's start with employee X. He brings in anywhere from 0 or 1 or 2 new clients. And the probabilities of each of those are 0.2, 0.4, and 0.4. Now, let's say the new employee brings in no new clients. He had a really bad week. Well, the experienced guy, he still could bring in either 3 or 4. So altogether, how many clients did they get? 3, 4. And these probabilities, by the way, are of course 0.5 and 0.5. What if the new guy did manage to get a client? Okay, well, then the experienced guy still could bring in 3 or 4. But now that means we could have a total of 4 new clients or 5 new clients. And again, these probabilities are 0.5 and 0.5. If the new guy had a really, really good week and he brings in 2 clients, the more experienced guy could still bring in 3 or 4. But that means our total could be either 5 or 6. And again, these probabilities are 0.5 and 0.5. And what we're going to do is we're going to take that information and make a new probability distribution that I'm calling C for the combined client list. So C stands for the number of clients combined, and then we'll have the probability of C. So how many clients could we end up with? There could be 3, there could be 4, there could be 5, or there could be 6. Now, what you can't do on this is you can't just say, well, this happened twice out of these 6, this happened twice out of the 6, and these happened 1 out of the 6 apiece. You have to look at these probabilities here. And you have to say, well, what's the probability that this 3 happens? Well, what is 0.2 times 0.5? Well, better yet, let's think of it. What is half of 0.2? This probability is 0.1. There's a 10% chance that we will get only 1 new client. Let's come over here and do this one. It's super easy. 0.5 times 0.4. What is half of 0.4? Well, that probability is 0.2. So there's a 20% chance that we might be able to pull in 6 new clients. This 4 is half of 0.2, so that's 0.1. This 4 is half of 0.4, which is 0.2, for a total of, there's a 30% chance that we might get 4 new clients. Now, if this is a legitimate probability distribution, these all have to add up to 100%. So we have 10, we have 40, 50, 60. This one must be 40%, which we can confirm because this would have been half of 0.4. So this would have been 0.2. This would have been half of 0.4. This would have also been 0.2 for a total of 0.4. So now I will let you have some practice. I want you to put this into your calculator, and I want you to come up with the new mu, the new range. Okay, we don't need that. The new range is 6 minus 3 is 3. We need a new variance and we need a new standard deviation. So let's see how fast you are in your calculator. Let's see how fast you are. I like to remind my students, we need to be efficient. Not only do you need to know how to do it, but you need to know how to do it quickly. If this was on an AP test, you don't want to waste time on calculator stuff. You done? All right, what'd you get for a mean for C? Mu sub C, remember these are also called like the expected value of C. So this would be in the long run, if these two employees kept combining their client list in the long run, on average, about how many new clients would they get? Nice, 4.7, nailed it. All right, again, you could kind of almost estimate when you look at this. You could say what's smack dab in between 3 and 6? 4.5. If all the probabilities were equal or evenly balanced, the answer would be 4.5. But you look at the probabilities, you're like, oh, actually, there's a little bit more at the high end, 60% versus 40%, and that's what nudged that one up a little bit. All right, and what did we get for variance? 0.81. And then when we square root that 0.81, you should have gotten 0.9. Nice. Okay. So, and doing that, that's actually reviewing 6.1. What I want to do is I want to use this example to concoct our rules for 6.2. And what I want you to do, and it says here, compare the mean of C to these mu's. Do you notice anything here that might be interesting? They really did add together. The mu of the first one, if I'm taking a random variable X, the number of clients from the first guy, and I'm adding it to Y, the number of clients from the second guy, to come up with a new C value. This is what we call combining random variables. X was a random variable. It could have been either 0, 1, or 2. Y was a random variable. It could be 3 or 4. But when I combine them together, it makes C. And the rule is, if you are combining random variables, you are literally allowed to add their mu's. You could say that the expected value for X added to the expected value for Y does equal the expected value for C. You need to know that rule, and it's not on the formula page. What about the ranges? They follow too, right? 2 plus 1 makes 3. Now, I threw this on here because it does work. I'm going to call it AP rare. I'm not sure I've ever even seen that on the AP. But you should know, it actually does work for ranges too, but they don't usually talk about that. All right, so does it work here? Can we do it with the variance? Does 56 added to 25 equal 81? It does. This is so cool. This is cool. So as long as you're adding random variables, you could do it with more than 2. Okay, if there's an X, Y, and a Z, you could do it. Okay, you can add the means, you can add the variances. This is actually a really big deal. You can't add sigmas. Way back when I first taught you guys about standard deviation in Algebra 2, and I talked about, I talked about how you need the variance to take the square root to get to the standard deviation. I made a big deal about the units. Variance was units squared, and that's why we square root it, because otherwise it doesn't make sense, etc. What I didn't tell you was, because a lot of people are like, well, why do we ever have a variance? If all we do is square root it to get the standard deviation, why do we ever care about variance? This is why, okay? This is why. If you're actually talking about within a data set, how much meaning does the variance have? Usually not much, because the units are messed up. Okay, what does it mean to be dollars squared or credit hours squared? It doesn't have meaning. But there are problems that you do in statistics that for calculation purposes, the variance is the only thing we can use, okay? So in an actual application setting, variance doesn't necessarily have a good application meaning. But this is big, okay? We now have a formula that works for the mean, the range, the variance. and standard deviation fails us, okay? All right, so next page, I think I just have a summary of these rules. I do. All right, there's a summary saying you're allowed to add means, and remember, you can do it more than one or more than two also. I said you can add variances, and I said standard deviations do not add. And I put a little note over here. I remind people, it kind of looks like the Pythagorean theorem. Okay, think about that. You know, x squared plus y squared could equal z squared, or a squared plus b squared equals c squared. Variance plus variance equals variance. It's got to be squared. And I reminded you here, neither formula is given on the formula page. You need to know these, okay? The mean of the sum of random variables will always be the sum of the individual means. But for variance, the variables must be independent. There is a formula for dependent variables, but it's beyond the scope of this class. Okay? To add variances, variables must be independent, and you never add standard deviations. Now, in terms of the independence, to be honest, what usually happens is when you get to a problem like this on the AP exam, or, you know, and there'll be a phrase like, you know, assume the variables are independent. It's almost like you barely have to think about it. It'll be a phrase in the problem, but it's a necessary phrase that just implies that you're allowed to use this rule. If it didn't tell you that, then technically you shouldn't be using it, okay? All right, so I wanted to do an example here that apply these new rules, and what I did was I went back to the same example that we were doing in class yesterday. So if you weren't here and you didn't watch the video, the example might not make much sense, but quick summary was we're at a community college and they were talking about how many credit hours students might enroll in. And on the first example, we said they might have 12 or 13 or 14, all the way up to 18. This is a smaller branch of the college. So now we're saying everybody either has 12 or 15 or 18. Nobody has 13, no one has 14 or 16 or 17, okay? Tuition is only $70 per credit hour. And let's see, find the mean and the standard deviation of y. Y is the number of credit hours. Okay, so let's save ourselves some time here. Actually, this one is, we can do this. Here we go again. If I covered up the probabilities, what number is smack dab in the middle of 12 and 18? 15. Are the probabilities equally balanced? Yeah, they are. Then I can tell you that the mu for y, which is also the expected value for y, is going to be 15. I wouldn't even need to type that in my calculator to figure that out. Okay? Now, if I actually wanted to get the standard deviation, now I would have to put this in my calculator. Okay? And I'll even put here, this is from the calculator. And I can help you out though. I'll tell you that the variance for y was 5.4, and the sigma for y, the standard deviation, was the square root of that 5.4, which is 2.32. And just a reminder, when you figure all of these out, we are finding out the average number here. So this is the average number of credit hours. This would be in hours squared, which really has no real world meaning. And because we square root it, we'd be now back in hours. Now, G is the tuition charge for a randomly selected student at this campus. What are the mean and standard deviation for G? So if you have to pay $70 per credit hour, and you take 12 credit hours, you could figure out how much money that would cost you, right? 70 times 12, 70 times 15, 70 times 18. But we're going to do this by saying we're going to create a new random variable. We're going to take 70 and multiply by all of our y values to create what's called G, tuition charge. This is an example of transforming a random variable. We're taking one variable y, and we are now turning it into G. This is called transforming. These are the rules we talked about yesterday. And the rules we talked about yesterday was, you can say that if I want now the mu for G, I literally can take the mu for Y and I can multiply by 70. I literally can just follow that rule. So I can say 70 times 15, which would be how much? 1050? Yeah. And this would now be in dollars because it's $70 per credit hour times a certain number of credit hours. Standard deviation follows the same rule. You can take the standard deviation from Y and multiply by that 70, and that'll give you the standard deviation for G. And again, these are rules that we talked about yesterday. So 70 times that 2.32, I have comes out to be 162.67. And again, this would be in dollars because it's $70 per credit hour. That's called transforming. We only took variable Y and then we altered it to create variable G. Okay, that's transforming. Now, A is the tuition charge for a student from the main campus and a student from this new campus. So this tuition charge was called G. If we went back to the other page, this was tuition at the other campus. So that expected value was 1318.50. That standard deviation was 185.05, which I repeated right here. Okay, but what we have to now look at, we have to say that if I take one student from the main campus, that was tuition, T, and now I'm going to combine it with someone from this new campus. They're now called G for their tuition. And together that equals tuition for both of them. So this is tuition from a student on the main campus, added to tuition for a student on the new campus, and this is now a total tuition. This is now called combining random variables. This is called combining random variables, okay? If I now want to calculate mu sub A, what we just discovered on the previous page, you are literally allowed to just say, well, what is the mu for T? What is the mu for G? Add them together. You're allowed to do that. If there was a third campus, I could add them too. So this answer is going to be the 1318.50 from yesterday plus the 1050 from today. And that comes out to be $2368.50 because that's total tuition. A student at the other campus and a student at this new campus. And what it means is after a whole bunch of kids have registered for classes at both campuses, if I randomly select one from campus, main campus, and one from this new campus, on average, I would expect the total tuition to be about that much money for the two students together. But standard deviation measures how far away from the mean could you be? So now we have to do standard deviation for A. And people are going to be tempted to say, well, I'm just going to take the standard deviation for T and I'm going to add it to the standard deviation for G. And guess what? That doesn't work. And that's why I said, think about it. It's supposed to kind of look like the Pythagorean theorem. I need this squared equals this squared plus this squared. You can only add variances. So now I'm going to have to come back and say, okay, well, what was sigma for T? 185.05. But I need to square that. Plus, what was sigma for G? 162.67. But I need to square that. And if I want that to come back and be the standard deviation, if you write it like this first, it will remind you a little bit about your order of operations. You actually have to type this in your calculator exactly like this, and then you will then have the variance for A. So I'm going to type in 185.05 squared. Help if I put my decimal in. Add it to 162.67 squared. That large number, that 60,705 number, that is my variance for A. So what do I still need to do? I need to square root that. 246.38. And that would also be in dollars. You cannot add the standard deviations. You are going to be so tempted. Think about writing it down like the Pythagorean theorem, and think about how you would solve the Pythagorean theorem. Okay, a squared plus b squared equals c squared. If you have to solve for c, you do a squared plus b squared, and then you square root that answer. That's the same thing you're doing here. Okay. One more page, and I think I'll stop for the day. Yeah. Okay. Now, when I talked about transforming variables yesterday, I know a lot of you weren't here, but you watched the video, and I'll say it in the video also. When you're transforming, adding and subtracting work the same way. I mean, isn't that what subtracting is? Just adding a negative number. Multiplying, dividing work the same way because they're really the same thing. Dividing is just multiplying by a reciprocal. So what we're going to test here, now that we have these rules for adding random variables, we're going to see if the same rules apply for subtracting. You've got to double check. Okay. All right. So I have the insurance agents again. Okay. But this time, instead of adding them together, now we're trying to figure out the difference between the two. Okay. In other words, how many more clients does the old guy pull in compared to the new guy? All right. So what I'm going to do now is I'm still going to start with the 0, the 1, and the 2 from the old guy. I am still going to do a fan out of a 3 and a 4 from the new guy. Okay. Still going to do those exact same numbers. But now what we're going to do is we're not going to add these together and say, look, we have a total of 3 clients. We're going to say 3 minus 0. Oh, the old guy pulled in 3 more than the new guy. Oh, the old guy pulled in 4 more than the new guy. The old guy pulled in 2 more than the new guy. 3 more. And what I'm doing now is I'm subtracting these instead of adding them. So now when I set up my probability distribution, this is now going to be called D, which is the difference in the number of clients. And the difference could be as small as 1. It could be a difference of 2, a difference of 3, or a difference of 4. And you would still have your same probabilities. Remember, this was 0.2, 0.4, 0.4, and these were all 0.5s. Now, it should not surprise you if you think about it, that we're going to come up with the same probabilities. They're going to be in different spots, though. So the probability of having a difference of 1, that's this trail. That's half of 40%, which is 20%. The 4 is only this trail, which is half of 20%, which is 10%. The 2 is this trail, and this trail. So we have in this trail half of 20%. In this trail, or excuse me, half of 40% makes 20%. And in this trail, it's the same thing. So this is 40%, and then this is 30%. Again, you get the same numbers we had on the other one. They're just kind of in different spots. We had 1, 3, 4, 2, 2, 4, 3, 1. Okay, so do it again for me. Put those in your calculator and get me the mu for D, get me the variance for D, and get me the sigma for D. Got them? Mu? 2.3. 2.3, yes. All right, before we move on, what do you think? Yeah. Say it again. Yeah, do you see it? Okay, I created these numbers by taking the more experienced guy who was Y, and I subtracted the new guy who was X. So I created D by doing Y minus X. And Andrew is right. The mu for D really does equal the mu for Y minus the mu for X. It works here. 3.5 minus 1.2 gives me that 2.3. It works. Doesn't work for the variance. What'd you get for variance? You got the same thing, didn't you? So it does work. Oh, wait a second. If it's the same thing, how does a 56 and a 25 combine to make an 81? You add them. You still add them. Even though we created D through subtraction, you still add the variances. You still add them. Even though you created the new random variable through subtraction, and you still can't do anything with the standard deviations. You can't add them, you can't subtract them. They don't have a pattern there. Excuse me. On the next page, I have the summary of these rules. Okay, for the mean. If you create a new random variable from two other ones through subtraction, you can subtract their means. You're allowed to do that. But the variances follow the same rule as before. The formula is the same as the one for adding random variables. It will still look like the Pythagorean theorem, okay? And I said these formulas still are not on your formula page. You have to know these. You have to know the rules for transforming and combining random variables, okay? And I just put a little note here. You guys remember law of cosines, right? Okay, so especially juniors, you guys just did your trig unit, right? If I put a 90 right here, what's the cosine of 90? 0. 0. Okay, it's on the paper too, by the way. Okay, but if the cosine of 90 is 0, it makes this whole thing disappear. Okay, and I actually talked about this when you had me in Algebra 2. The law of cosines becomes the Pythagorean theorem when you're working in a right triangle, because you have a 90-degree corner, which means the cosine is 0. Okay, the Pythagorean theorem is nothing more than the law of cosines in a right triangle. Okay, it just makes that disappear. There is a similar equation for non-independent random variables, and it looks like this. The variance equals the variance plus the variance minus, okay, what is all this mess? Okay, you guys have seen, I think it's rho, right? I think you guys have used rho, I think, in physics, okay? So if rho is the correlation between the two variables, but if the variables are independent, then there is no correlation, and that disappears and it falls out, okay? This is the formula that you use for non-independent random variables. We're not going to get into that, but I think it's kind of cool that when you look at it, it really does have a similarity to the law of cosines and the Pythagorean theorem, okay? So some of you who end up in a higher level stat course in college, you might see that again, but all right. We technically have gone through enough information that you can continue the work on 6-2 homework, okay? The last example that I have here that I'll go through on Monday with you, but it actually is kind of putting all the information together, okay? So if you don't want to finish the 6-2 homework over the weekend, you don't have to, but then you got to do it all on Monday, okay? On Monday, I'll finish the notes, and then definitely Monday, we have to finish up 6-2. Okay. Did you get my remind about the end of the semester? All right. So I had my dates numbered wrong. I was off a week. We are going to make it comfortably through chapter 6 before the holidays. Okay. And if you check the calendar, you can see that where it's going to land. Okay. When we come back from the holidays, we're going to go right into exam review, and we'll take our exam then still earlier than your other exams. But unfortunately, we won't get the exam out of the way before the holidays. But like I said, you will walk out of here, chapter 6 will be done, and when we come back, we'll launch into 2 or 3 days of prepping for that exam, and I'll probably give you the exam over the course of 2 days, okay?